be divided into 16, and each core will be assigned with that particular substructure. So that will form the parallel processing, which reduces the solution time. So if you see in feast, lot of drastically there is a reduction in the time taken to solve the problem. So this all we are going to see in the today's session. So feast is the first finite element analysis software which is developed by India and available for Indian community. So the origin of the software is way back 1967, where Dr. APJ Abdul Kalam sir, when he was working in the ISRO department, he initiated the program of making India self-reliant, self-dependent. So he asked various people to come and collaborate for the development of our own software, and this is how the free software came into existence. So till 2014, this free software was being used uh, by ISRO only, because it was their own code. So it was being used by ISRO for more than 20-30 years. And after 2014, the scientists found that this software has a very good capability, at par capability, and this software can be commercialized, and almost all companies, organization, institutes can use this software for finite element analysis. So this is how in 2014 the software was released, and now like 4 or 5 years this software has been in market. It has penetrated a lot of government organizations, private organizations, and academic institutes, IITs, NITs, almost all colleges are using this feast for their finite element analysis. So this finite element phases. So as you know, there are any you consider any software independent, like it may be ANSYS, it may be Nastran, Hypermesh, any other software. So you will find these are the phases which we have to generally follow. Like first of all, we have to create the model. It may be in the same software, or we can import from the other softwares like CATIA, SolidWorks, SolidEdge, and all. So whatever CAD modeling softwares are available, from there you can import. So after importing, we generally go for meshing. After the mesh generation, we apply the loads, boundary condition, we assign the physical property and the material properties. Material physical properties in the sense, like for example, if it is a beam, we have to assign the cross section. If it is a plate, we have to assign a thickness. So these are the general properties we assign. Then after this application of loads and boundary conditions, we set the analysis type. And then we generally run the solver, and we get the output in the form of tables, contours, animations, XY plots, and arrow plots. All are available. So as we know, any finite element software has three phases: pre-processor, post-processor, and solver. So in Feast, the pre-processor is called as pre-win, where CAD modeling, mesh generation, application of loads and boundary conditions can be done. So in Feast, we have our own graphic user interface where the input data can be given to the software. Then we have this analysis. In the analysis, you can see we have our own solvers. So all these solvers are self-developed. That is, it is being developed by ISRO. And then we have the post-processor capability, where we get the results in the form of tables, animations, XY plots. So that is also available in the same GUI. That means this Feast is one package having integration of pre-processor, solver, and the post-processor application. So the input file, that is a data file, will be transferred to the solver, and once the solution is done, the output file will come back to the prewin for post processing. So our prewin is basically a pre and a post processor for finite element software. And for this, our software provides almost 800 plus commands for geometric modeling, mesh generation, data file preparation, data translation. Almost all kind of options are available in this preprocessor. Then it mimics CAD-like features. So the third point, you can see it mimics CAD-like features. CAD-like features in the sense, like for example, you have seen CAD softwares where we can create a CAD model, that is all geometric properties we generally assign. Like extrusion, transformation tools are available, like extrusion, glide, sweep, rotate, translate, and all. So the same options are available in Feast, but the same options are available on the mesh. So this is a very, I'll say, a very good tool, a unique capability Feast has. Like with minimum geometry, we can generate maximum mesh. So the elements can be translated, it can be rotated, it can be extruded, glide, sweep, rotate, almost all that we are going to see in the later slides. Then we have import and export facility, which also allow user to mesh the model in Feast and solve it in any other software. Like if you are familiar with ANSYS, you can mesh it in Feast and you can export the model to ANSYS and you can solve it in ANSYS. Even vice versa, it is possible. Like if you want to mesh it in the ANSYS, if you want to solve in Feast, even that is possible. You simply mesh it in Feast, you simply mesh it in ANSYS and import that that meshed model into Feast for further analysis. Similarly, rest of the softwares also you can pass on the information, like Nastran, that is BDF format. In Nastran, you can see hypermesh will also come, because even in hypermesh we have to export in the form of Nastran deck.bdf format. Then NISA as well as Mark options are available where we can export the CAD model, meshed model. So these are the transformation tools which we were discussing. Like we can, so all these options are available with the mesh. This is not with the geometry. With the geometry also, it has the capability. But in this slide, we are going to show you the capability with the mesh. So you can see here sweep option, where 2D elements can be swept along a particular axis with number of segments. So all these 2D elements will be converted into 3D elements. No need of geometry. Similarly, you can rotate. Yeah. So you can rotate the mesh, you can translate the mesh, you can mirror, you can sweep, glide, and all functionalities are available with the Feast software. Not only this, Feast has excellent meshing capability, where both map mesh as well as auto mesh capability we have. Like first, I would like to introduce the auto meshing capability. You can see here we have some set of curves. So you can see this. You can see the auto curve option, where there are three curves. First is the complete bigger rectangle, or let us consider a square. Inside there will be second curve, that is a circle, and third there is a rectangle. So there is no surface in between. Only we have three curves which are closed curves. First is square. Inside that there is a circle and a rectangle. But with this, software has a capability to mesh it directly without forming any triangular element. All the elements will be quad. The software will take care that none of the elements will form triad. So without any surface, we can mesh with perfect quad elements. Here also, in the second option, you can see we have auto node. So if you have node, let us consider if it is a thin shell cylinder. On the thin shell cylinder, if it is open at the top, if your professor come and say we have to fill the top surface with some elements. So you have to go back to your CAD modeling software. You have to create surface on the top, and then you have to remesh it. But here in Feast, simply you can select the top surface and you can start meshing. Or second option is auto node, where you can simply select the nodes present at the boundaries and it will generate elements. No need of surface. Simply select the nodes present at the top. It will automatically generate elements. None of the element will form tria in this case also. Map meshing capability is similar to hypermesh, where you can simply use your left click to increase the mesh density, right click to decrease the mesh density, and you can create the manual mesh, and then you can extrude. Then you can extrude, glide, and sweep. Other transformation tools can be used on these 2D elements. So versatile tool for meshing, I'll say. Once we go to our GUI, I'll show you what exactly we have the capabilities. Then, for example, here you can see cutout on mesh option we have on the left, on the right side top corner. We have this cutout on mesh option, where if it is a doubly curved surface, you can see it is a doubly curved surface, and it is completely mesh. Now, if your senior comes and says we require one hole onto the geometry or onto the mesh. So if you are using any other software, you have to go back to your CAD modeling software application, and then we have to generate a hole or a cutout, and then we have to update the mesh, and then you will find that the mesh is completely disturbed. Or even you can use washers to generate a mesh. But again, outside the region of washer, we have to adjust the mesh, which takes some time. But here, on a single click, we can create this kind of mesh. You can see. So just on a single click, this kind of mesh pattern can be generated. So with minimum time, complete quad elements and completely uniform mesh pattern can be generated in Feast. So the Feast modules, I would like to explain. We have in Feast currently, we have this static analysis, that is linear static analysis, as well as non-linear static analysis capability is available. Then we have the frequency domain as well as time domain analysis. In frequency domain, we have free vibration, which is also called as modal analysis in some other softwares. Then we have this eigenvalue analysis, which is called as buckling analysis, where we get the buckling load factor. In the free vibration or modal analysis, we get the natural frequency and the mode shifts of the structure. Then in transient analysis, we have the time dependent inputs. So we generally perform transient analysis. Then we have this frequency response analysis, which is also called as the harmonic analysis, where the forcing function of frequency can be, or the forcing function can be defined. And then we have this random response in this indeterministic load input can be given. Response spectrum analysis, which is also called as seismic analysis in some of the softwares, even that is possible in Feast. Then we have this fluid structure interaction. In some, we generally call it as one-way FSI, because the effect of the fluid on the structure can be analyzed, and we can get the dynamic properties of the structure by using this fluid structure interaction. To give an example, let us consider a water tank, which is overhead water tank, and when the tank is empty, its dynamic characteristics will be different, and when it is filled with some liquid, the mass will increase, and then the dynamic characteristics will be completely different. So that kind of analysis can be done using this fluid structure interaction option. Then we have base excitation, where this is important in civil engineering applications, where the complete multi-story building can be excited from the base, and the response can be analyzed using basic citations. Inertia relief method is again quite similar to static analysis, except here the boundary conditions are not added. Then we have this viscoelastic analysis for rubber kind of material. For fracture mechanics, we have extended finite element methods that we are using in FEAST. Then we have this thermal analysis. In thermal, we have this. I'll just move this one. Yeah. So in thermal analysis, we have conduction, convection, as well as radiation. Steady state as well as transient heat transfer is possible. Then we have electrostatic simulation, and in the future version or the next version, which is going to get released after 3 days, so it has electromagnetic simulation capability as well. So a lot of unique, I'll say almost all the structural capabilities are available in FEAST, so mainly used for structural analysis. Along with this, lot of elements, library, material models, linear solvers, eigensolvers are available in FEAST with constraint equations like single point, multi-point constraint, rigid links, and all we have. Other option is like import and export of CB matrix, that is Crick-Brampton reduced matrix, which is a very, I'll say, good tool available in FEAST as well as in Nastran. So, for example, uh, if I'll just give you a good example, like if Bharat Forge is specialized in manufacturing of crankshafts, and if let us consider if John Deere or any other company is manufacturing a complete vehicle. So the that Bharat Forge company will not give any CAD model or finite element model to this the to the team of another company because of the secrecy issues. So instead, they can export the CB matrix, which is a reduced matrix where the user cannot see what exactly the CAD model is or the mesh model is, but the software will understand how and what are the loads and boundary conditions, how are they are acting, and the effect can be analyzed on the complete structure. So this is a good, I'll say, command available in FEAST. Now you can see there are a lot of standards available in market. Like we have FSSAI for food. For jewelry, we have Hallmark as a standard. We have ISS standard, MIL standard, and other standards are available. So which gives a standardization to any of the product. So similarly, for any finite element analysis software, for any finite element analysis software, there is one standard which is called as NAFEMS, which stands for National Agency for Finite Element Methods and Standards. It is totally UK-based association dedicated to FEA and CFD. So they will give some set of commands. They will give some set of commands, and because that problem, they will give some set of problems, and that we have to solve it in our software. Only then they will certify the software, and then only we can commercialize the product into the market. So the FEAST software is benchmarked for the accuracy, speed, robustness, and ease of use. And the solver, which is FEAST SMT, is benchmark for the solution accuracy. And some problems I'll just try to skip. I'll just briefly introduce these problems. Like this is a patch test, and all this in the information like geometric properties, material properties, boundary condition, nodal information, everything is given by NAFEM, and we have to achieve these theoretical values. So here you can see we have the theoretical values, and and these are the FEAST results. Similarly, another problem I would like to show, like this is a simple problem of a plate with a hole under tension. So as we know, if you are applying a sigma, we should get 3 sigma. So here you can see the NAFEM's target is 3, which is hand calculated result, NAFEM target, and this is the FEAST result, and this is the NASTRAN result. Loads and all this information is given by NAFEMs. So we cannot change the single nodal information as well. So with this nodal information or with these elements, we have to achieve the results. So you can see FEAST is giving like 2.82, which is quite closer to NAFEM's target. So we can even get a result nearer to 3, but we have to increase the mesh size, the order of the element. But since this is given by NAFEMs, we cannot change the single data as well here. These are few examples of ISRO where these are the real life problems which they have solved in FEAST. This is the modal analysis of payloader, where degree of freedom is greater than 1 lakh. Then this is the wing of a launch vehicle, reusable launch vehicle, where degrees of freedom were greater than 18 lakhs. So a lot of complex modeling has been done using FEAST and analyzed it. You can see this is the vibration fixture, and it has been modeled and analyzed, and these are the degrees of freedom you can see. I'll just skip some of these slides. So you can see some of the benchmark problems for BRC, that is Baba Atomic Research Center, then NRB, IITs. We have solved various benchmark problems for them, and which are compared with some other commercial softwares like ANSYS. So this is the response analysis for the multi-degree of freedom structure. So for civil engineering, here we have this water tank, which has cement mortar from inside outside, and at the center there are some mesh grids, and it has been analyzed in FEAST. For civil application, here you can see this is the frequency response of the structure. Again, for civil application, here the soil structure interaction. This is a very complicated phenomena where the soil and the structure is having the interaction, and that can be modeled by using spring elements. So the soil structure interaction model, here you can see some of the analysis for mechanical engineering applications, robotic applications can be seen here using FEAST and ANSYS. So these are on the right side, you can see these are the ANSYS results. On the left side, these are the FEAST results. Then here you can see the complete robotic arm is analyzed using FEAST. The complete modeling, meshing, and model analysis is being carried out in FEAST. And on the right side, you can see these are the FEAST result. On the left side, these are the ANSYS results, quite comparable results. So I'll skip some of the examples. So here, currently more than 1,000 plus licenses are being used across India. Various government organizations, almost all government organizations are using FEAST, and major IITs and NITs NIT Rourkela, NIT Jamshedpur, they are using Feast as the application or the software for finite element analysis, and many MOUs has been signed with Feast software for the future development. So I'll quickly introduce to the complete GUI, and we'll try to solve some of the problems using Feast software. But I would like to tell all the participants to please download and install the software. Downloading link I has already been sent by email, and if you have downloaded, please install the software. If there is any error in the installation, you can please let me know. Okay, so before solving any problem, I would like to first give you a simple introduction to the Feast software or the complete GUI, that is the graphic user interface. So if you are familiar with any other CAD meshing software or finite element software, I'll say, if you are familiar with Hypermesh, you will find some drop-down options are available like this. So here you can see some drop-down options. If you are familiar with ANSYS APDL, you will find some command-free kind of options are available on the left side of your screen. So you can simply go and expand the field, and you can invoke the command. So same options like ANSYS are available on this panel on the left side of your screen, which is called as command tree. If you are familiar with Hypermesh, drop-down options are available at the top. If you are familiar with NISA or Adams, you can have this command line where you can simply type the name of the command. Here you can see we can simply type the name of the command and we can invoke the same command. Some shortcuts are available on the left side. You can see vertical strip we have, which is nothing but a shortcut button where all the shortcut options are available. Like you can simply create a point from here, point, line, curve, surfaces, volumes, elements, meshing, deletion, everything is available on the left side vertical strip. That is the shortcut button. So to invoke any command, we have almost 4 to 5 options. Okay. Now, so here I like to now tell you in this file option. In file option, we have this new, open, save, and save as options. So if you want to create a new file, you can go to new. Then if you want to open any model from the other softwares like STEP or IGS, you can go to open. You can simply go to file, open, and here we have this default file which is generated is the .prj format. Is the .prj. Yeah. Okay. So here we have this .prj format. If you click here, we have this .data file. Then we have .pdf format. This for other softwares like Hypermesh, we have .pdf format. NISA. For CAD models, we have STEP and IGS. From here, you can see we can import the CAD model. So you can go to File, Open, and there you can import the CAD model and you can start meshing. Similarly, we have this export option called Create Data File, where you can export the model, in the to the other softwares like Nastran, NISA, Mark, and ANSYS, and some free format options. So we have import and export facility available here in file option. Okay. So I'll just go to C window, C drive. Once the software is installed, it will have the installation in this program files 86. You can just go to this folder where FEAST 2020 folder is available. You can simply double click and open the folder where documentation folder is available. You can enter into the documentation folder, and now here you can see we have complete theoretical manual, user manual, preview manual. This all I'll explain now. Then we have this tutorial and release guide. So I'll just quickly open this preview manual. I will open. So here you can see, once you open the preview manual, it will show you the complete I'll say commands. For example, if you are not familiar how to create the point, or if you stuck somewhere like how to create a line or any like elements and all, you can simply you can refer this, like I'll go to point. It will show the options available for creating point. I'll use this first option. So now here you can see, once you click on the first option, it will show how to use the command, what are the options available to use this command. So complete information is available in the help file. For example, I'll give one more example. If I want to create some elements, I'll go to element. I want to create a spring element, so I'll go to spring element. So here, once you click on the spring element, it will give you the complete information of the spring element, how to use it, and so here you can see how what is node set 1, node set 2, all the information is available. So this is regarding the preview file. I'll just close it. So this is regarding the preview file. Similarly, some theoretical manuals are also available. So I'll just open the theoretical manual. So if somebody is interested in the theoretical background of the software, if you want some theoretical background, he can go to this theoretical manual content, and then he can choose as per his requirement. Like if he wants to see the capabilities, so he can, if he wants to see the how the static condensation is done, he can simply go to that application. I'll close this also. Similarly, we have this user manual where what commands user should give, all the information is available. And lastly, here we have this tutorials. I'll just open the tutorial. So here, this is the tutorial where almost.
Hello.
Yes.
Sir, we got, when we downloaded, only 3 folders in document. Fiesta 2018 R2 tutorial, Preview theoretical manual, and SMT help. That's all. Only 3 files are there in documentation. There is no other files, whatever you are telling.
You're saying you have tutorial, theoretical manual.
Preview theoretical manual is there, tutorial is there, SMT help.
SMT help, yes. So the names are different. SMT help is nothing but the user manual, Previn theoretical manual means both are combined. Previn theoretical manual, both are combined. You can open and then you can see. Otherwise, you can simply go to help in feast. You can go to help and you can open help file. So from here also you can open. So even if it is not available in this folder, you can directly go to feast software and you can go to help file, or else you can have this Previn and this theoretical manual is nothing but same. It is combined, and user manual means feast SMT manual. Okay. Now, once this is done, now I'll just explain some geometric features, and we can solve a simple static problem. Now, I'll like to simply solve a beam problem first, and in the next session, we will solve a problem of a 2D problem. We'll solve of a plate, and tomorrow we'll see some dynamic analysis. Today we'll perform the static analysis. So in geometry, you can see we have options to create point, curve, surface, volume, plane, local coordinate systems, and some Boolean operations are available. So before that, I'd like to tell, here we have some options like tabs. So first is the main tab, where all these options are available. That is, command options are available. In the edit tab, whatever inputs we are giving, so those inputs, if you want to edit, or those editable inputs will be available in the edit tab. Show tab is used for masking and unmasking the features or the entities like node, element, volume, point, curve, surfaces, and all. Colors is basically used for all the entities. It may be geometric entity, it may be finite element entities. So here we have this background option. In the color settings, in the colors, at the bottom you can see we have black, white. If somebody wants to customize as per his requirement, he can customize, he can store, and wherever required he can even load the color combination. So I'll just make it white for better visibility. I'll return back to main tab. In the geometries, now here I'd like to take one simple problem so that it will be easy for us to follow the steps. So now we will see how step by step we can solve any problem. So the reference is taken from this beam design formula, which here in moment diagram. So page number, everything is given. Analysis which we are going to perform is static analysis, and the elements which we are going to use are beam elements. So you can see, we'll consider a simple cantilever beam which is fixed at one side, and at the other side we are going to apply a point load of 3000 pounds. The geometric properties and material properties are given at the bottom. I'll just scroll down. So the Young's modulus is in PSI, that is, it is steel 30E6 PSI is the Young's modulus. Poisson's ratio for beam problems or for 1D problems, Poisson's ratio is not taken into consideration. So Poisson effect for 1D is not taken into account. So here it is given as 0. Or the geometric properties, length is 300 inches and the cross section is 30 by 10 inches. And the load application is point load, which is 3000 pounds in the downward direction. Okay. So now to solve this problem in PEAST, we will just first go to geometry. We'll go to geometry, key point, create by XYZ. We'll go to geometry, key point, create by XYZ. Simply double click to invoke the command. I'll double click so that the command will get activated. So this is the execution box where whatever commands you are going to use, it will get activated here. The blue strip represents the message box. So here, whatever messages are there, warnings or messages, it will be highlighted in the message box.
Sir, let us try.
Coordinate data, yes. So coordinate data is default 0, 0, 0. That means we are creating one point which is at the origin. Coordinate type here, it shows that default we are working into Cartesian coordinate system. Similarly, we have another coordinate systems like cylindrical coordinate system, spherical coordinate system, and then local coordinate system. So default 0 is for Cartesian coordinate system, 1 is for cylindrical coordinate system, 2 for spherical coordinate system. Now, in this example, since you can see the force is acting in the downward direction, that is nothing but we are working in the Cartesian coordinate system. Now, let us take one example where the force is acted at some particular angle. In that case, we have to create our own local coordinate system. So currently, I'll just keep this coordinate system at 0 and entity ID. That means we have to give some labels to the points. So I'll label it as 1 and I'll click on apply. On the screen, you can see one point is created. I'll just go to settings and I'll increase the size of the point so that it will be visible to this on the screen. I'll also increase the size of node and a line. Okay. So first point we have created at 0, 0, 0. I'll just press escape. I'll just repeat the process so that it will be clear to all. I'll go to geometry, key point, create by XYZ. I'll double click to invoke the command. And here the coordinate data will be 0, 0, 0. And coordinate type will be 0 and entity ID I'll put it as 1 and I'll click on apply. So one point will be generated at the origin. Second point we have to create at some distance of 300 inches.
Sir, how did you increase the size of the point? How did you increase the size of the point?
Yeah, to increase the size of the point, we will go to settings option. So here in the tabs, you can see these are all tabs: main, edit, show, color, and settings. So in that, you can go to settings. In the settings, we have the sizes option. Third option is sizes. In that size, you can see the size of the point.
Okay.
Yeah. Now, okay, I'll create another point at distance of 300 inches in X direction. So I'll type 300 in X direction. Coordinate system will be 0, that is in the Cartesian coordinate system. Entity ID, I'll name it as 2, entity ID. And I'll click on apply. Now you can see a second point is generated at some distance of 300 inches. Now, in this
sir, 1 minute. Sir, when we click on settings, we are getting XY plane, XY plane, YZ plane, and XZ plane. That's all. Where is the size?
What, ma'am? Hello.
When we click on the settings,
yes,
we are getting only XY plane, YZ plane, and XZ plane. The size of the points we are not able to get.
Yes. Yes. For that, we have to click on sizes. So you are in default plane now. You can see on the screen, on the screen, you can see it is default plane. You click on sizes. You click on third option, which is sizes.
Okay.
And
Yeah.
now you can change the size of the point. Yes.
Yes, sir. Yes, sir. Got it. Got it.
Once it is done, you again click on main tab, main menu. I'm just hovering my mouse on the option so that you will come back to the command options.
Okay.
Yeah. Okay. So now the second point we have created at a distance of 300. I would like to tell basically unit independent. Nowhere we have set the units. Even other softwares like Abacus, Nastran are unit independent softwares. So the user has to be consistent with the unit system. If in this case, here you can see if this is in inches, if the length of the beam is in inches, the cross sections are available in inches. So the user has to be consistent with the unit system. In that case, Young's modulus should be in PSI. If you are considering in mm, if the length is in mm and the load value is in newtons, so we have to give the Young's modulus in newtons per mm square, which is nothing but megapascal. So the user has to be consistent. Now, once these 2 points are created,
sir, how to create the second point?
You can go to geometry key point create by XYZ. You can go to geometry key point create by XYZ.
Yeah, but how you have moved? Two points are in different locations, no? Left side and right side.
Yes.
You will get like
on my screen also it is same, no? It is. So I'll tell again. So I'll go to geometry key point create by XYZ. The first point will create at origin, that is 0, 0, 0, and second point will create at 300 inches distance with name as 2. So only I'll go to points. So here you can see we have 2 points now. First point at origin and second point at distance of 300 inches. So once these 2 points are created, we have to join these 2 points by line. So for that, we will go to geometry. We'll go to geometry, curve, create, line. And in that line option, we have to select these 2 points. So I'll go to geometry, curve, create. I'll double click on line command. So here you can see end points we have to choose. End points are nothing but these are the geometric points. So here we have some filters at the top. You can see we have the C filter, P filter, N, which stands for point filter, node filter, and snap to corner, where it will take the vertices also. So I'll use point filter. I'll choose first point and the second point. So 2 points are selected. I'll just repeat the process. Okay. Once these 2 points are generated, I'll go to geometry, curve, create, line. I'll double click
sir,
on
wait
line.
1 minute, 1 minute, wait. That is, the second point is not created for me. I think we have to.
Madam, I think if we go like this, it will take almost double the time. So what I request, let him complete one complete problem, and then we can go for any doubts that you have. If we do like this, it would take a lot of time.
Sir, this is not the first FDP I'm attending. Everybody will tell us to do parallelly, so that only we can explore it. Otherwise, what is the use of having a FDP? It's okay, fine.
Okay.
Okay, I'll just quickly tell how to create a second point. I'll just create a new file. Okay. So I'll go to geometry, key point, create by XYZ. So first point I'll create at the origin, that is 0, 0, 0. I'll click on apply. Once you click on apply, still you are in the same command. Until you press escape, you are in the same command. So here you can simply type 300 inches, and you can label it as point number 2. And then you can click on apply. So second point will be generated. And then you can join these 2 points by a line. So I'll double click on line and I'll select first point and the second point. So a line is generated. I'll go to geometry, curve, create line, and here I'll use this point filter, and I'll simply just select first point and the second point. So a line will be generated. Once this line is generated, you can see our geometry is done. Our first step, that is geometry, is done. So the options are arranged in a sequence so that a user will not forget any of the command. Like for example, first we'll create a geometry. Once the geometry is done, we will go to mesh. After meshing only, we will apply loads and boundary condition. Then only we'll apply the material properties. So that if we follow these steps, we will not forget anything, and smoothly we can run the analysis. Once the geometry is done, we will go to mesh now. Once the geometry is done, we'll go to mesh. In mesh, I'll go to FE mesh. In mesh, I'll go to FE mesh. In FE mesh, we have certain options. I'll explain these options. First option is called bar element or bar command. It's not element, actually a command. The name of the command is bar. But this option can be used for meshing 1D. So 1D geometries, if it is there in your complete model, you can use this bar command for 1D mesh. Default, this has beam elements. I'll just double click on this bar command. So this, whatever meshing we will do, it will have default beam elements. So curve IDs, I'll click on this curve. Curve IDs, I'll click on this curve. And like other softwares, we have the subdivision options where you can use your left mouse button to increase the mesh density and right mouse button to decrease the mesh density. I'll use left mouse button to increase the mesh density and right mouse button to decrease the mesh density. So in this case, I'll only use 2 elements, not more than 2. Okay, because we'll check what will be the results with some only 2 elements. So in the subdivisions, I'll keep 2 elements. Node, here we have this type, that is 2 noded and 3 noded, that is linear element and higher order element. So I'll keep linear element. Biasing is used for keeping fine mesh to one side and coarse mesh to other side. So I'll just keep this biasing so that uniform mesh will be generated. So now here you can see we have divided our complete cantilever model into 2 elements. Once this meshing is done, I'll move on with the loads and boundary condition. I'll just go to loads and boundary condition. Here we have 3 options like structural, heat transfer, and electromagnetic. Currently, we are interested to perform the static analysis, so I'll go to structural. In structural, here we have some options like boundary conditions, that is displacement constraint. I'll double click on this displacement constraint to invoke the command. So here you can see we have invoked the displacement constraint command. Now here you can see it is cantilever beam which is fixed at one side. So at one side I'll fix. So node number 2, I'll fix node number 2. Or you can fix even node number 1. So either way, either you can select node number 1 and you can arrest it, and on node number 2 we can apply loads. So I'll just select node 1 in this case. Node 1 I'll select. Boundary condition values. Here you can see BC value is nothing but the boundary condition values, and we have a dialog box here. Simply I'll click on this dialog box. So it will ask us to arrest the degrees of freedom. So default, the beam element which we are using is having 6 degrees of freedom per node. So I'll arrest 6 degrees of freedom of that particular node, and I'll click on apply. Here look, LCS ID. LCS ID is 0. 0 means it is in Cartesian coordinate system. So whatever boundary conditions we are adding, it is in Cartesian coordinate system. Set ID, software will take it as default 1, 2, 3, and so on. For example, if you are keeping it blank, software will take it as 1. If you are applying another boundary condition, it will take it as 2, and so on. Labeling here indicates you can apply any label annotation to the boundary conditions. So I'll keep it blank. So the boundary condition is now added. After applying the boundary condition, I'll go to point load. So here you can see we have to apply a point load of 3000 pounds. So I'll go to loads. In that structural, once we have applied the displacement constraint, now we will move on to the point load. Double click to invoke the command. Select node number 2 and apply the value, that is magnitude, as 3000, component as y component. That means it will act in y direction. So here we are into, you can see here local coordinate system is 0. That means in Cartesian coordinate we are going to apply the load in y direction, but it should be applied in negative direction of y. So I'll just give the value in negative direction. So minus indicates it will act in the negative direction of this y component. If you want to give any label, like I'll just label it as point load. Simply I'll just rename it as point load, and I'll click on apply. So a point load is also applied. Here you can see a point load we have to apply of 3000 pounds. So that we have applied at node number 2. Node number 1 is fixed. So as discussed, we are just following the sequence. Geometry we have done. We have meshed it with 2 elements. On the first, in the loads, we have applied the structural displacement at one node and point load to the other side. So this loads and boundary condition is done. Now we will move on to property. Now we will move on to property section. In the properties, we have to define the material property and the physical property. In the material property, we have to select, in the material property, we have to select structural. So I'll just go to structural, isotropic. I'll apply the isotropic material properties. I'll apply the isotropic material properties. So element IDs, I'll select element IDs as all. So I think video is stuck. So just a moment. Just a moment. Just a minute. I'm checking the internet connection.
नाही तर काय म्हणायचं नाही तर कधी म्हटलं.
Yeah, now is it visible?
Yes, yes. This is visible.
Okay. Yeah. So once the geometry, mesh, and loads and boundary conditions are applied, I'll go to property, material. I'll go to property, material, structural, isotropic. So since we are applying the isotropic material, we are assuming uniform material. So I'll choose isotropic. Elements, we have to choose all the elements. In this model, we have only 2 elements. So I'll just use this box selection option. I'm simply using, I'll just drag my mouse so that all the elements are selected. In the material data, we have a dialog box. In material data, we have a dialog box. So here we have to give the material data. Material is steel, that is 30 E6 psi. So I'll type 30 E6. So only this value is sufficient to solve the static problem. Since it is a 1D problem, Young's modulus will not come into picture. So for 2D and 3D, Young's modulus will come into picture. So at that moment, we can apply the value of this Poisson's ratio. Rest we can keep it blank because others also are not going to affect. Alpha value will be used when we are solving the alpha delta T problem, that is thermal stresses problems. So currently we are not using that. So this alpha value also we are not applying. And density is used for calculating the natural frequency or the vibration problems. So in that cases, we will use density. For static analysis, there is no need for density. So I'll just keep it blank and I'll click on OK. I'll click on OK. So I'll click on OK and that material is added. Once the material is added, the another option we have to give is the physical or another command which we have to use is the physical property, that is beam property. Since in this case we have till now we have not given any data regarding the cross section, so we have to define to the software that this is the cross section. So the cross section can be defined in the physical beam properties, standard section, add, and here element IDs we have to choose all. Element IDs I'll choose all, so you can simply type here ALL all. You can type ALL all, and the cross section shape can be assigned by clicking on this dialog box and choosing a rectangle, of 30 by 10. So H is 30, so H is 30 and this is the 10. So cross section also we have added. I'll just repeat the process again so that it will be easy for all to understand. I'll just press Ctrl Z. So to apply the cross section, I'll go to properties, physical, beam properties, standard section, and add. Here we have to select the element IDs. So we have only two elements. This is the first element and this is the second element. These two elements I will choose. Cross section, we will choose rectangle cross section of 30 by 10. I'll select and I'll click on apply. To rotate the model, I'll press Control from the keyboard and left mouse button so that I can simply rotate the screen or rotate the model. Control right click for panning. I'll use Control right click for pan and Control scroll for zoom in, zoom out. I'll use Control left click for rotation, Control right click for panning, and Control scroll for zoom in, zoom out. Okay. Now, once the physical properties are defined, next step is to set the analysis type. Analysis type. Here we have the type of analysis. Here we have the type of analysis. So in that I'll choose analysis type is static. First option is static. So I'll click on apply. And I will save the model because nowhere we have saved the file. So I'll go to file and I'll simply save this model. I'll save this model with name as cantilever beam. I'll save this file with name as cantilever beam. And then we have option to solve the model. In the analysis, we have run solver option. So simply double click, so it will start solving the problem. Before solving, it will show that the solver type is feast SMT, analysis type is static, and your model is saved at this particular location with the input file as .dat, and at the same file at the same location .out file will be generated. That is the output file. I'll click on yes, it will start solving the problem. If there is any error, it will show in the message box. And here we have the progress bar. On the left right bottom corner, we have the progress bar where it will show the time of analysis. Okay, I'll click on yes, so it will start running the solver. In the message box, you can see it has solved. It has solved the problem. Once the problem is solved, you can go to post. You can go to post, deform shape. You can simply click on deform shape option, and you can click on superimpose. You can click on superimpose. So you will get the value of deflection. You can go to post, deform shape, and you will get the value of deformation. So here the deformation is 0.04024 inches. So this is the formula. This is the formula for calculating the deflection and the stress values. Theoretically, if you calculate by using this formula, you will get the value of deflection to be around 0.04 inches, and in feast we are getting 0.04024. So with the two elements also, we are getting the results nearby this value. Stress value, bending stress is 600. That is nothing but PSI, because the value of Young's modulus we have applied in PSI, length in inches, everything, the geometry properties in inches, load value in LB. That's now. So the stress, bending stress, we are getting in PSI. To get the value of bending stress in the post, get the value of bending stress in the post, after deform shape, you can go to beam plots. In the beam plots, you can see the stress contour. You can go to stress contour, and you can plot the stress in the XY plane. You can get the value of bending stress and top and bottom, that is 614. Here you can see the value of stress is 600 and we are getting 614 with two elements. Similarly, you can plot the bending moment Similarly, you can plot the shear force and bending moment by going to post force diagram and shear one. Here you can see the value of shear force is same, that is whatever load value, that is the value of P which we are applied minus 3000, the same value we will get in the shear force. And in the bending moment, I'll plot BM2. In the BM2, I'll click on apply. You will find this is the value of bending moment, that is 3000. Here I'll just scroll down. Here you can see the 3000 pound load is acted at a distance of 300 inches. So if you multiply P into L, which is nothing but the bending moment, so you can see the maximum value of bending moment in the software is this one. So in post, all the options are available to plot the results. Like for example, if you want to see the results in the form of reaction forces, I'll choose the reaction force and you can plot the results. So all these results you can copy and you can paste it into Excel. You can plot the graphs and animations, XY plots. So almost all options are available in this post option. If you have any doubt, you can please type in the chat box, or else you can unmute your mic and you can please ask. There's one question in the chat box. You said two elements. Which are they? The 2 points. Okay. So here you can see the complete length of this beam is 300 inches that we have divided into 2 elements. So this is one element. So I'll go to labeling option. I'll go to labeling option and I'll just click on the elements. Click on the elements so that it will show the element. So this is first element and this is the second element. So we have 2 elements. Okay. So anybody, if they have any questions, you can please ask.
Sir?
Yes, sir. Please.
Yeah. Sir, in the presentation, you told about that functionalities of the software. So we got this trial version, right? So all these options are available in the trial version or not? That was my question.
Yes, sir. Yes, sir. All these options are available in the trial version. So, like, if I'll just go to the slides. Whatever slides I have shown. So, whatever commands or whatever modules are available in the professional version or the research version, that same options are available in the trial version. Only thing is that in trial version there is a node limitation of 5,000. There's a node limitation of 5,000, but it can suffice our need. It can solve 5,000 node means you can even mesh bigger geometries as well. So the trial version has almost all capabilities what research version has.
If we are open for that, you can please unmute, or you can also type in chat and we will take that question. Okay, then. So I see no questions in chat also. Right.
There is one question in the chat box, like what will be the time period of trial version? So it is available for 6 months, and every 6 months there will be a new release from ISRO. So even now in December, on December 11, there is a NAFED. I'll just show you the brochure. So every June and December, there will be a new release of the software. So now in this December, that is 11th and 12th, there is a program from ISRO where they will release a latest version of free software, which will work for the trial version will work for 6 months. Again, there will be a new release or new update in that. But if you can please register to this event, that will be really nice, because lot of scientists and professors from IITs, NITs will be joining this session, and lot of new, I'll say, lot of new discussions on the MOU or codes and implementation of codes will be discussed. So if you can please register to this event, that will be really nice. So you can, if for registration, you can simply type on Google NAFED 2020 registrations. You will get directed to the registration page.
Right. So if there are any more questions, I request participants to unmute and ask.